In this lesson, you are going to see how easy it is to find the length of a side of a right triangle using sine, cosine, and tangent. Before we get started, let's quickly review some trigonometry basics. We are going to label each side of our right triangle. One side will be the hypotenuse, another side will be the opposite side, and the third side will be the adjacent side. The side across from the 90-degree angle is always the hypotenuse. If we look at our triangle from the point of view of angle A, the side across from angle A is the opposite side. The remaining side, which is touching angle A, will be the adjacent side. In order to find the sine of angle A, we divide the side opposite angle A by the hypotenuse. In order to find the cosine of angle A, we divide the adjacent side by the hypotenuse. And in order to find the tangent of angle A, we divide the opposite side by the adjacent side. If these concepts are completely new to you, I highly recommend you first watch my video on finding the sine, cosine, and tangent ratio, which you can find on the Math Discipline channel. Before we get started, you'll need a scientific calculator. Your calculator needs to have the sine, cosine, and tangent buttons. If you have an iPhone, just turn the iPhone calculator sideways and it'll turn into a scientific calculator which has the sine, cosine, and tangent buttons. Android phones also include a scientific calculator. In example 1, we know the measure of angle A, which is 27 degrees. We know the length of side AC, which is 8. We do not know the length of side BC, which is represented by the variable x. And we do not know the length of side AB, which is represented by the variable y. In order to use our sine, cosine, and tangent ratios, we have to use one of the two angles which are not 90 degrees. Since we know the measure of angle A, 27 degrees, we will label our sides from the point of view of angle A. The side across from the 90-degree angle is the hypotenuse. The side across from angle A is the opposite side. The remaining side is the adjacent side. We have to solve for both x and y, but we can only solve for one at a time. Let's start by solving for x. X is the length of the opposite side. Now, in order to use our trigonometric ratios, let's compare it to the side that we do know, which is side AC, which has a length of 8. So we are comparing the opposite side to the adjacent side. Looking at our trigonometric ratios, we can see that tangent is the ratio that compares the opposite side to the adjacent side. Since the tangent of angle A equals the opposite side divided by the adjacent side, let's substitute the measure of angle A, 27 degrees, for the letter A, and let's substitute the variable x for the length of the opposite side and the number 8 for the length of the adjacent side. This gives us the equation tangent of 27 degrees equals x over 8. Now that we have set up the equation, we will use our algebra skills to solve this basic one-step equation. In order to solve for x, we want to isolate the variable x on one side of the equation and get everything else to the other side of the equation. So we need to get rid of the 8 on the right hand side of our equation. There are two ways to think about how to do that. Since x is being divided by 8, we want to do the inverse operation. The inverse of division is multiplication. So in order to undo the division by 8, we will multiply by 8. And whatever you do to one side of the equation, you must also do to the other side of the equation. When we do this, the 8's on the right hand side of our equation cancel out because 8 divided by 8 equals 1. The shortcut method is to just think of this as if you are moving the 8 to the left side of the equation and doing the opposite operation of division, which is multiplication. So now we have x is equal to 8 times the tangent of 27 degrees. In order to simplify this last part of our equation, we need to use our scientific calculators. This part is very important, so you should pay close attention. Scientific calculators have different rules as to how you are supposed to enter your calculations into the calculator in order to get the correct answer. I will explain two different methods. Which method is right for you depends on which calculator you are using. Here is method number 1. Regardless of which calculator you are using, you must always make sure that your calculator is in degree mode. This button is usually labeled DEG. If your calculator is not in degree mode, even if you enter everything else correctly, you will get the wrong answer. So with your calculator in degree mode, enter 8 times tangent 27. You may need to close the parentheses in your calculator. If that's the case, press the close parentheses button. Now hit the equals button. If this method works for your calculator, your answer should be approximately 4.076. I'll repeat the steps. In degree mode, press 8 times tangent 27 equals. Method number 2 is used on many calculators, including the scientific calculator on the iPhone. So if you are using an iPhone, this is the method you should use. First, make sure your calculator calculator is in degree mode. Then enter 8 times 27 tangent equals, and your answer should be approximately 4.076. Once again, in degree mode, enter 8 times 27 tangent equals. In the first method, you are pressing the tangent button before you enter 27. In the second method, you are entering 27 before you press the tangent button. Okay, so if we round our answer to the nearest hundredth, x is approximately 4.08. So the length of side BC is approximately 4.08. Now that we have solved for x, we need to solve for y. If we look at our triangle, we can see that y represents the length of our hypotenuse. Now, since we know the length of our opposite side, we could use the length of the opposite side to solve for y, but it's always possible that we could have made a mistake in our calculations. So it is safer to use the length of the side that was given to you at the start of the problem, side AC, which has a length of 8. So we're going to compare our hypotenuse side to our adjacent side. Looking at our trigonometric ratios, we can see that cosine is the ratio that compares the adjacent side to the hypotenuse side. So cosine of A equals the adjacent side divided by the hypotenuse side. Now let's substitute the measure of angle A, 27 degrees, for A, and the length of the adjacent side over the length of the hypotenuse side, so 8 over y. We have cosine of 27 degrees equals 8 over y. Now just like before, in order to solve for our variable y, we need to isolate our variable on one side of the equation. In our equation, the number 8 is being divided by y, so in order to move the y to the other side of the equation, we do the opposite of division, which is multiplication. So we multiply both sides of our equation by y. When we do that, the y's on the right hand side of our equation cancel out because y divided by y equals 1. The shortcut method is to just think of this as if you are moving the variable y to the left side of the equation and doing the opposite of division, which is multiplication. So now we have y times the cosine of 27 degrees equals 8. We are still trying to get our variable y isolated on one side of the equation and everything else to the other side of the equation, which means we need to move the cosine of 27 degrees to the other side of the equation. Since y is being multiplied by the cosine of 27 degrees, we need to do the opposite of multiplying by cosine of 27 degrees, which would be dividing by the cosine of 27 degrees. And whatever we do to one side of our equation, we must do to both sides of the equation. So we divide both sides of our equation by the cosine of 27 degrees. The shortcut method is to move cosine of 27 degrees to the right side of our equation and do the opposite of multiplication, which is division. So now our equation reads y equals 8 divided by the cosine of 27 degrees. Now that we have our y variable isolated, we can go to our calculators to compute this final part. Method number 1. Make sure your calculator is in degree mode. Enter 8 divided by cosine 27. You may need to close the parentheses. Now press equals. Your answer should be approximately 8.98. I'll repeat the steps. In degree mode, press 8 divided by cosine 27 equals. Method number 2. With your calculator in degree mode, enter 8 divided by 27 cosine equals. Again, that's 8 divided by 27 cosine equals. So y is equal to approximately 8.98 if we round our answer to the nearest hundredth. We have solved for both x and y. The keys to these problems are setting them up correctly and knowing how to solve algebraic equations. Example 2. We know the length of side KL, which is 47. We do not know the length of side JL, which is represented by the variable x. And we do not know the length of side JK, which is represented by the variable y. We must solve for both x and y. Since we know the measure of angle J, 64 degrees, we will label our sides from the point of view of angle J. The side across from the 90-degree angle is the hypotenuse. The side across from angle J is the opposite side. The remaining side is the adjacent side. We have to solve for both x and y, but we can only solve for one at a time. So let's start by solving for x. X is the length of the hypotenuse. Now, in order to use our trigonometric ratios, let's compare it to the side that we do know, which is side KL, which has a length of 47. So we are comparing the opposite side and the hypotenuse side. Looking at our trigonometric ratios, we can see that sine is the ratio that compares the opposite side to the hypotenuse side. Since the sine of angle J equals the opposite side divided by the hypotenuse hypotenuse side, let's substitute the measure of angle J, 64 degrees, for the letter J. Substitute 47 for the length of the opposite side and the variable x for the length of the hypotenuse. This gives us the equation sine of 64 degrees equals 47 over x. Now that we have set up the equation, we will use our algebra skills to solve this simple equation. We want to get the variable x isolated on one side of the equation. Since 47 is being divided by x, we'll do the inverse operation, which means we'll multiply both sides of our equation by x, or you can just think of it as moving x to the left and doing the opposite of division. We still haven't isolated the x variable. Now we need to get sine of 64 degrees to the other side. Since x is being multiplied by the sine of 64 degrees, we'll do the inverse operation, which means we'll divide both sides of our equation by the sine of 64 degrees. This eliminates it from the left side and moves sine of 64 degrees to the right hand side of our equation. Now we have x equals 47 divided by the sine of 64 degrees. Now let's go to our calculators. Again, I'll go over two different methods for entering this equation into your calculator. Method number 1, with your calculator in degree mode, enter 47 divided by sine 64, close the parentheses if necessary, equals. Your answer should be approximately 52.29. Again, in degree mode, press 47 divided by sine 64 equals. Method number 2. Again, this is the method to use if you are using the scientific calculator on your iPhone. In degree mode, enter 47 divided by 64 sine equals. Once again, in degree mode, 47 divided by 64 sine equals. Rounding our answer to the nearest hundredth, x is approximately 52.29. So the length of the hypotenuse is approximately 52.29. Now that we have solved for x, we need to solve for y. If we look at our triangle, we can see that y represents the length of the adjacent side. Even though we now know the length of the hypotenuse, it's a good idea to use the length of the side that was given to you in the problem to avoid possible errors that could occur if you calculated your hypotenuse wrong or if you rounded wrong. Since the side that was given to us was the opposite side, we will compare the adjacent side with the opposite side. We can see that tangent is the ratio that compares the opposite side to the adjacent side, so that is the ratio that we will use to solve for y. So tangent of j equals the opposite side divided by the adjacent side. Now let's substitute the measure of angle j, 64 degrees, for j and the length of the opposite side over the length of the adjacent side, so 47 over y. So we have tangent of 64 degrees equals 47 over y. We move the variable y to the left side of our equation by multiplying both sides of our equation by y. This cancels out the y's on the right hand side. You can also think of this as just moving y to the left and doing the opposite of division, which is multiplication. Now we are still trying to isolate the variable y, so let's move tangent of 64 degrees to the right by doing the opposite of multiplication, which would be dividing both sides of our equation by tangent of 64 degrees. This gives us y equals 47 divided by tangent of 64 degrees. On your calculator, for method number 1, in degree mode, enter 47 divided by tangent 64, close parentheses if necessary, equals. Your answer should be approximately 22.92. Again, in degree mode, enter 47 divided by tangent 64 equals. Method number 2, with your calculator in degree mode, enter 47 divided by 64 tangent equals. Again, that's 47 divided by 64 tangent equals. So y is equal to approximately 22.92 if we round our answer to the nearest hundredth. We have solved for both x and y. Now let's apply these concepts to a word problem. Example 3. A 15-foot ramp is placed against the wall. What is the distance from the ground to the top of the ramp? What is the distance from the wall to the bottom of the ramp? The figure shown is a right triangle. We can see that one side is 15 feet long. The other two sides are unknown. We can also see that the measure of angle F is 12 degrees. Now, in case you haven't noticed, this problem is exactly the same type of problem that we saw in examples 1 and 2. This type of word problem is very common when studying these types of trigonometry problems. You'll often see this type of problem disguised as either a ladder leaning against the building, which creates a right triangle, or as some sort of ramp, which is the case in this problem. As we did in examples 1 and 2, let's begin by labeling our sides. Since we know that angle F has a measure of 12 degrees, let's label our sides from the point of view of angle F. The side across from the 90-degree angle is our hypotenuse. The side across from angle F is our opposite side. The remaining side is the adjacent side. Let's start by solving for x. We are given the length of our hypotenuse, 15 feet. And we are trying to solve for x, which is the opposite side. So we will need to compare the opposite side to the hypotenuse. Sine is the ratio that compares the opposite side to the hypotenuse side, so we will use the sine ratio to solve for x. The sine of f will equal the opposite side divided by the hypotenuse side. We substitute the values from our problem and we get sine of 12 degrees equals x over 15. In order to isolate our x variable, we are going to move the 15 to the left side of our equation by doing the opposite of dividing by 15, which would be multiplying both sides of our equation by 15. Or you can just think of it as moving 15 to the left and doing the opposite of division, which is multiplication. So x is equal to 15 times the sine of 12 degrees. Now let's go to our calculators. If you are using method number 1, make sure your calculator is in degree mode and enter 15 times sine 12, close parentheses if necessary, and press the equal button. Again, that's 15 times sine 12 equals. Your answer should be approximately 3.12. If you are using method number 2 with your calculator in degree mode, enter 15 times 12 sine equals. Again, that's 15 times 12 sine equals. Rounding our answer to the nearest hundredth gives us x is approximately 3.12 feet. Now that we know what x is, let's solve for y. The variable y represents the length of our adjacent side. We know the hypotenuse has a length of 15 feet, so we are going to compare the adjacent side to the hypotenuse side. Cosine is the trigonometric ratio that compares the adjacent side to the hypotenuse side, so we will use cosine to solve for y. The cosine of f equals the adjacent side over the hypotenuse side. Substituting the values from our problem gives us cosine of 12 degrees equals y over 15. In order to isolate the y variable, we will move 15 to the left side of our equation by doing the opposite of dividing by 15, which means we will multiply both sides of our equation by 15. This gives us y equals 15 times the cosine of 12 degrees. Now let's go to our calculators. For method number 1, with your calculator in degree mode, enter 15 times cosine 12, close parentheses if necessary, and press the equal button. Your answer should be approximately 14.67. Again, that's 15 times cosine 12 equals. For method number 2, with your calculator in degree mode, enter 15 times 12 cosine equals. Again, that's 15 times 12 cosine equals. If we round our answer to the nearest hundredth, y is approximately 14.67 feet. Okay, many students are confused by the fact that some of these problems are solved by multiplication and some are solved by division. Let's look at an example using a very simple equation that should help clear up any confusion. We all know that 10 divided by 2 is equal to 5. For the sake of this example, let's put the 5 on the left side and the 10 divided by 2 on the right side. So 5 is equal to 10 divided by 2. Now let's write this same equation, but let's replace the number 10 with the variable x. Let's pretend that this is an equation that we have to solve for x and we don't know what x is, even though we can see that this x has to equal 10. And let's write another version of this equation, except this time, let's replace the number 2 with the variable x. Let's also pretend that this is an equation that we have to solve for x and we don't know what x is, even though we can see that this x has to equal 2. Now let's go through the process of solving our equation on the left. We want to isolate the x variable on one side of the equation, so we have to move the number 2 to the left left side. We do this by doing the opposite of dividing by 2, which is multiplying both sides of our equation by 2. This causes the 2's on the right side to cancel out. Now we have x is equal to 2 times 5, so x equals 10. Now let's compare how our equation started to how our equation ended. When we started, the x variable was on the top of our fraction. We ended up moving our denominator 2 to the left side of our equation and multiplying. Now let's take this equation from example 1. As you can see, it is the exact same type of equation as the equation on the left. We have a term, in this case, the tangent of 27 degrees, which is equal to x divided by a number. In order to isolate the x variable, we multiply both sides of our equation by 8. The 8's on the right hand side cancel out and we're left with x is equal to 8 times the tangent of 27 degrees. When we multiply this in our calculators, we get approximately 4.08. When we started this problem, the variable x was on the top of our fraction. In order to isolate the x, we moved the denominator 8 to the left and multiplied. So when the equation consists of a number which is equal to a fraction with the variable in the numerator, which means the top of the fraction, you just move the denominator, the number on the bottom of the fraction, to the left and you do multiplication. Now let's look at how we solve the equation 5 equals 10 divided by x. Our variable x is in the denominator. We want to move it out of the denominator. We can do this by doing the opposite of dividing by x, which is multiplying by x. And whatever we do to one side of the equation, we must do to both sides of our equation. So we multiply both sides by x. This cancels out the x's on the right hand side. Now we have 5x equals 10. We still need to get the x variable by itself and move the 5 to the other side of the equation. Since 5x means 5 times x, we move the 5 by doing the opposite of multiplying by 5, which would be dividing by 5. We do this to both sides of our equation. This causes the 5's on the left hand side to cancel out. So now we have x is equal to 10 divided by 5. We simplify this equation and get x equals 2. Now let's backtrack and compare the beginning of this problem to the end of this problem. When we started, our variable x was in the denominator or the bottom of our fraction. Pay special attention to where the 5 and the x are located. Now let's go down to where our equation ended right before we got our answer. As you can see, this equation looks exactly the same as our equation at the top, except that the 5 and the x have now switched places. Understanding how this relationship works gives you a really fast shortcut that allows you to speed through these problems. Once you understand this, when you encounter a similar problem, you can just take those numbers or variables and switch their places and save yourself several steps of work. Let's compare this equation to another equation that we had in example 1. The cosine of 27 degrees equals 8 divided by y. As you can see, this equation is in the same style as the equation we just solved. We have a term, the cosine of 27 degrees, which is equal to a number 8 divided by a variable y. In order to solve this equation, we must isolate the variable y on one side of our equation. Since we are dividing by y, we undo this by doing the opposite, which is to multiply both sides of our equation by y. This causes the y's on the right hand side to cancel out. Now we have y times the cosine of 27 degrees equals 8. We are still trying to isolate the y variable, so we need to move the cosine of 27 degrees to the other side. Since the y is multiplying with the cosine of 27 degrees, we need to do the inverse operation. So we will divide both sides of our equation by the cosine of 27 degrees. The cosines of 27 degrees on the left-hand side cancel out, and we're left with y is equal to 8 divided by the cosine of 27 degrees. When we simplify this in our calculators, we get approximately 8.98. Now let's compare the beginning of this problem to where we ended up. At the beginning, the variable y was at the bottom of our fraction. After moving several of the terms around, the cosine of 27 degrees and the variable y switched places, just like they did in our previous example. So when the equation consists of a number, which is equal to a fraction with the variable in the denominator, the number on the left-hand side switches places with the variable in our denominator, and you divide. Again, understanding these relationships will help you immensely in solving these problems. I want to point out that this technique that I just showed you, where I took a very simple example to help you understand something that seemed difficult, is an excellent way of figuring your way out of problems when you get stuck. When a problem seems difficult or confusing, think of how you would solve a much easier version of that same problem and then follow those exact same steps. So to summarize, when the variable is on the top, you take the denominator, move it to the left, and multiply. When the variable is on the bottom, you take the variable in the denominator and you have it switch places with a number or term on the other side of the equation, and then you divide. It's time to practice what you just learned. You'll need a piece of paper, a pencil or a pen, and a scientific calculator. You have 30 seconds to answer these 3 questions. You should round your answers to the nearest hundredths if necessary. That means 2 places after the decimal point. If you need more time, just pause the video. After the video, we'll look at the solutions. Your 30 seconds begins right now. Okay, time's up. Let's look at the solutions. For practice problem number 1, we begin by identifying our sides. Since we are given the measure of angle B, which is 48 degrees, we'll identify our sides from the point of view of angle B. The side across from the 90-degree angle is the hypotenuse. The side across from angle B is our opposite side. The remaining side is the adjacent side. We are given the length of side AC, which is 36. This is our opposite side. We are trying to solve for x, which is the length of our adjacent side. So we will compare the opposite side to the adjacent side, which is the tangent ratio. The tangent of angle B is the opposite side divided by the adjacent side. We substitute the values in our problem and get the tangent of 48 degrees equals 36 divided by x. We want to isolate the variable x, so let's move it to the left of our equation by multiplying both sides of our equation by x. The x's on the right cancel out, and we now have x times the tangent of 48 degrees equals 36. We still need to isolate x, so that means we need to move the tangent of 48 degrees to the other side of our equation. We do that by doing the opposite of multiplying by the tangent of 48 degrees, which means we divide both sides of our equation by the tangent of 48 degrees. The tangent of 48 degrees cancels out on the left side of our equation. Now we have x equals 36 divided by the tangent of 48 degrees. Divide 36 by tangent of 48 degrees in your calculator, and rounding our answer to the nearest hundredth, we get x is approximately 32.41. Practice problem number 2. Since we are given the measure of angle F, 24 degrees, let's start by identifying our sides from the point of view of angle F. The side across from our 90-degree angle is our hypotenuse. The side across from angle F is our opposite side. The remaining side is the adjacent side. We are given the length of side EF, which is 52. That is our adjacent side. We are trying to solve for x, which is the length of side DF, which is our hypotenuse side. So we are comparing the adjacent side to the hypotenuse side, and that is the cosine ratio. So the cosine of f is equal to the adjacent side divided by the hypotenuse side. We substitute our given values from our problem, and we get the cosine of 24 degrees is equal to 52 divided by x. We want to isolate the variable x on one side of our equation. Since it's in our denominator, let's move it from the right side to the left side. We do this by doing the opposite of what it is currently doing. Since 52 is being divided by x, let's do the opposite operation and multiply both sides of our equation by x. This causes the x's on the right hand side to cancel out. Now we have x times the cosine of 24 degrees equals 52. We still need to move the cosine of 24 degrees to the other side in order to get x by itself. Since cosine of 24 degrees is multiplying with x, we do the opposite operation, which means dividing both sides of our equation by the cosine of 24 degrees. The cosine of 24 degrees cancels out on the left hand side, and now we have x equals 52 divided by cosine of 24 degrees. We divide 52 by the cosine of 24 degrees in our calculator, and we get our answer, which is x equals approximately 56.92. Practice problem number 3. Since we are given the measure of angle L, 63 degrees, let's identify our sides from the point of view of angle L. The side across from our 90-degree angle is the hypotenuse. The side across from angle L is our opposite side. The remaining side is our adjacent side. We are given the length of our hypotenuse side, 27. We need to find the length of side JK, which is our opposite side. The ratio that compares the opposite side to the hypotenuse is sine. So the sine of angle L equals the opposite side side divided by the hypotenuse. We substitute the values from our problem and get the sine of 63 degrees equals x over 27. We want to get our variable x by itself, so let's move the 27 to the left side of the equation by doing the opposite of dividing by 27, which is multiplying both sides of our equation by 27. The 27s on the right cancel out, and we have 27 times sine of 63 degrees equals x. We multiply this in our calculators and we get our answer, which is x is approximately 24.06. Let everyone know how well you did in the comments. If you found this video helpful, make sure to hit that like and subscribe button and to check out the other trigonometry videos on the Math Discipline channel. Thanks for watching.